In this video, we're going to look at the Pythagorean theorem. All right, so before you attempt this lesson, just know some basics. What is a right triangle? All right, just a triangle with a 90-degree angle. How to solve equations with square roots and how to simplify square roots. So all these things are going to come together to help us with the Pythagorean theorem. The Pythagorean theorem, you definitely heard before. It says the sum of the squares of the legs of a right triangle are equal to the square of the hypotenuse. And that's just a really complicated way of saying if I take the two short sides of a right triangle, A and B, and I square them, I get the hypotenuse, the long side, hypotenuse across from the right angle, C squared. All right, so that's the Pythagorean theorem, very popular in every math class, so you've definitely seen it before. But we're just going to work on this as a way to practice using our square roots. So here's the general strategy for using the Pythagorean theorem. The most important thing is to identify the hypotenuse of the right triangle. And why is that? Because the hypotenuse is that C, the one that goes by itself on one side of the equation. And then the remaining two values, the legs, are going to go on the other side of the equation. So the most common mistake that students make is putting the hypotenuse with one of the legs. Just make sure the hypotenuse is always by itself. All right, then you basically just solve for the thing that you're looking for using your square roots. All right, so find the exact value of the missing side. Whenever you see exact value in math, it means don't use a calculator. The exact value, we want to leave fractions and square roots and all that stuff in our final answer. All right, so the first thing, identify the hypotenuse. The hypotenuse is the missing side, so we can call that whatever you want. I'll just call it x because x is generally what we use in algebra. So x squared is going to be on one side of the equation. On the other side of the equation, we're going to get the square root of 3 squared plus 1 squared. All right, so always make sure the hypotenuse is by itself. And now I want to solve for x. Generally, you want to simplify a bit before you start worrying about solving. The square root of 3 squared, square roots and squares are opposite, so they cancel. And then 1 squared, 1 times 1 is 1, and that gives me 4. All right, so this problem simplifies to x squared equals 4. To get rid of the squared, I take the square root, just like we just saw, they're opposites of each other. So get x equals 2. But whenever you're solving an equation that involves a square root, you want to put a plus or minus. And it's good to practice that plus or minus, even though it's going to turn out one of the answers doesn't make sense for the problem, because it doesn't make sense to have a side length being a negative. So my final answer, the missing side, has length 2. It's important to remember this when you're actually talking about just the equation part of it. That plus or minus is there, but in the application of the Pythagorean theorem, only the positive answer makes sense. So similar, find the missing side. The missing side is here. We'll call that x. But I always start off with what is the hypotenuse. The hypotenuse is across from the right angle 6. So I'm going to get 6 squared equals x squared plus 4 squared. So always make sure that hypotenuse is by itself. And now some simplifying, actually doing these exponents. And now we want to solve this equation for x. So when we're solving these equations for x, we want to get the x squared part by itself. So then I can use my square root. So now I can take the square root of both sides. And x equals plus or minus the square root of 20. And unlike the previous problem where the square root just came out really nicely, this one we actually had to simplify our square root. The square root of 20 is not a nice number because we want the exact value. We don't want to put it into a decimal because that would cause us to round and not get the exact value. So you just have to remember our perfect squares. If any of these divide the number in the square root, I can simplify the square root. In this case, the square root of 20 is divisible by 4. And 4, because it's a perfect square, it behaves nicely with the square root. I get the 2 on the outside. This 4 passes through the square root and becomes that 2. Square root of 4 is 2. And again, final answer for the Pythagorean theorem problem doesn't make sense to have the plus or minus. It just makes sense to have a positive side length. So that is the missing side length, 2 times the square root of 5. And it's fully simplified. So here's one for you to try and find the exact value of this missing side here. And I pause the video and work on the problem, and I'll show you the answer in 3, 2, 1. And the solution to the Pythagorean equation is plus or minus 5. But again, we only want the positive answer for our actual side length. So the answer is 5. All right, so go ahead and practice using the Pythagorean theorem. Definitely something you've done before. But just make sure you're really careful with always having the hypotenuse by itself on one side of your equation, and just working with square roots. All right, whether you're squaring a square root, they cancel out, or using a square root to solve the equation, just getting comfortable with using these roots.